Hi, this is Vignesh Ganesan from Kaliri.in e-learning platform. Now we are going to know how to model this shaped parts in a simplest way using the Solidworks. Okay, let's start to design. This is the exact components with the actual dimensions in a three different views. One is in top view, another one is in front view, next one is in side view. First is select a top line and create a new sketch. Draw a polygonal profile, that is an hexagon profile, initiating a six different sides. From the center point, draw at to the particular positions. Then fix this vertical alignment now using a linear constraints. Then fix this with this horizontal dimensions of 100 mm. Once we fix this enough profile, create a solid body. If you look at it, there is a small steps behind that. One is an overall 50 mm, another one is a small step 20 mm. But what I'm going to do is, I'm going to initiate the total dimensions of 50 mm. That is an entire solid body. Okay, how I can get this exact shape from this area? Let's take a deep look on this. Draw a circular profile that is an exactly related to this top plane itself. From the top view, I am going to initiate the dimensions for each and every area. From Start from the center point. And what is the dimensions for the circular profile? It is having the diameter value of 40 mm. That is a 20 mm radius, so 40 mm of value. Next one is an R profile, which must be tangential to the top edges. So we need to draw a line profile which must be a symmetrical positions. Before that, which just coincide the two opposite endpoints. One is an origin point, another one is an opposite center point. So close these two opposite points now. Afterwards, we are going to draw a line profile. Either we can use an offset entities also, or we can simply draw a line profile. First is selecting this all different three different lines, then fix this within parallel constraints and then symmetrical constraints. It is almost fixed within each other. Then mention the dimension value. If you initiate the offset distance, there is some kind of error occurred at the particular location. That's why I avoid an offset entities and initiating a new dimensions with the new profiles. Then draw an arc profile, 3-point arc. Draw a rough profile first, then fix this with a tangential connection at three different sides. This is the first one, initiate the tangential constraints, then fix this with the tangential constraints on the opposite line profile, same as like another opposite line profile. Once we fix these three different positions, then trim this excess number of the entities. Here, we can use a normal trim entities, that is in quick trim, or we can prefer a closed corner. Here I just trim this excess number of the portions. Almost we get that. Now we are going to do by creating a circular pattern. So choose this entities first. That is an overall entities first, and select this circular sketch pattern and decreasing the instance into three different numbers. Fix this using a dimension radius. Either we can prefer a dimension angular spacing or we can prefer an equal spacing. I prefer an equal spacing type. Okay, almost we get that with this and a constraint process. Then just eliminate the excess number of the entities using trim entities values. Trim each of its every individual entities right now, one by one. Once we remove the excess number of the entities portions, almost we get the closed profiles. Here, we need to eliminate the outer portion. Why I am drawing the inner exact profile means, using this inner exact profiles only, we are going to eliminate the outer most portions. So once we draw the profile, using this, choose an extruder cut. What is the total dimensions? It is 50 mm. From the bottom end, there is an offset distance of 20 mm. Rest of that, we get a 30 mm. Also choose an flip side to cut. If you choose a flip side to cut, from the profile, the excess entities automatically gets removed. That is what the exact use of flip side to cut. Excluded from this current profile, all the excess entities will be eliminated. That is what the exact thing. Now choose the stop faces and draw one connecting line between that. Before that, we need to draw a circular profile. That is a pitch circle. Then mention with this diameter value. So selecting the circular profile, it must be the diameter of 38 mm radius. So 38 into 2, we get the diameter 76 mm. Then change it into a construction line because it is only for a reference purpose, not the output one. Now from the center point, I am going to draw a 2 or more circle. Before that, just look at the outermost circle, that is an outer diameter. It is 12 mm of radius. So draw the primary circle first. Then draw a two connecting center line, starting point and closing this with this origin point. Then use and coincide with this construction line. Okay. Use the smart dimension. We just select and initiating the dimensions value of 24 mm diameter. That is what the radius of 12 mm. Then close this with the two opposite line profiles. Here also I not prefer an offset edit because it requires some kind of an error. That's why if you want to avoid that, we need to create a new profile in this particular portions. Mate it with the tangential constraint and prefer a parallel constraints also. Parallel constraint as well as a tangential constraint. Two additional geometrical constraints. Then eliminate the excess number of the portions. Also trim these entities. One, this is another one. Almost it is an open to all kind of profiles. This just to close these two opposite points. Here we got that choosing these profiles and choose a circular pattern directly from the command manager, or you can simply prefer by choosing this command search command area, type a circular sketch pattern, choosing this and reducing the instance number into 3 different numbers, then click OK. Now I want to fix this instance, so selecting the center point which must be made with this pitch circle also. Exit the sketch and form a pocket up to the distance of, what is the distance? It is 10 mm. So mention 10 mm here. Yes, we got that. Now selecting this top end and draw a circular profile from the two concentric points. This is the first one. This is the second one. Then fix these two circle profiles now. Choose the smart dimensions. What is the diameter for this value? 6 mm radius. So the diameter is nothing but 12 mm. Once we initiated that, holding your control button, selecting the two profiles and mention this equal constraints. Now selecting this profile, same as like either we can prefer in command manager or I can type a command of circular sketch pattern. Choosing this and form a number of the instance. That is a 3 different numbers. One of this particular profile is fixed under concentric constraint. Almost the rest of the profiles is fixed now. Exit the sketch and create a pocket. Choose an extruder cut through wall and eliminate the excess area. Now select a front plane. Draw an angular line profile for a chamfer positions. Instead of creating a chamfer is not suitable for this particular operation. So we need to draw a profile in a front plane, closing these entities and fix this with the smart dimensions. That is an offset distance is 25 mm. If you look at this top view, it is clearly mentioned under the bottom of its area, it is a 25 mm. Once we got that, just mention the value of 25 mm here. Then fix this profile. The angular profile is 25 degree. Closing this, draw a vertical center line, then form a revolve cut. Exit the sketch, choosing a revolve cut, form a revolve cut up to a 360 degree. Yes, we got the complete solid body in these portions using this flip side to cut and the revolve cut portions in this area. If you want to learn a full courses means you can choose our platform Kaliri.in. Here we provide a full professional course, specialized course, primary course. Also prepare your resume and online portfolio